All right, so we're ready to look at the divorce rate worksheet, which is the last worksheet in chapter 5. So we're given some data, this spreadsheet that compares various divorce and marriage rates, right? So you want to pay attention. You read, what the titles are, what the years are, and what these numbers mean, right? So we have 1, 2, 3, 4 different rates, right, for this data. So we have the U.S. population, number of divorces occurring that year, number of marriages occurring in that year, total number of marriages in the population, and then these rates, right? And this is from the U.S. Department of Health and Human Services. So number 1 asks us to, for the year 2004, use each of the 4 rates in a sentence, right? So we're using these numbers, right? So these are the sentences that I would use, right? So I'm going to type them right to the right here. So we make the font pretty big, right? So for the first one, for the 3.8, you could say, in 2004, there were 3.8 divorces per 1,000 people in the population, right? So the next number in 7.8, we could say in 2004, there were 7.8 marriages per 1,000 people in the population, right? For the fourth number, 48.7, we could say in 2004, there were 48.7 divorces per 100 marriages in that year. And then in 2004, there were 18.3 divorces per 1,000 marriages total in the population, right? So that's number 1, right? I took all 4 of those numbers and put them in a sentence. And notice how specific I'm being, right? I'm stating the year and restating that rate, right? So that way it makes sense, right? So that's an important skill that we're trying to emphasize in this class, right? Being able to take those numbers and what do those numbers mean, right? So number 2 says, which of these rates do you feel is the best way to report divorce rates, right? Explain. So something that we have to keep in mind is that comparing the divorces to the population seems arbitrary since only married people can be divorced, right? So it seems silly to take divorces and compare it to the population. So comparing the marriages total seems to be more meaningful, right? So when we take divorces and compare it to the total marriages, right? So this last column, that seems to be the best, right? So that's what I would put for number 2. And then number 3 says, which rate seems to support the idea that half of all marriages end in divorce, right? So there's 2 ways to support this. So let me erase this. I'll do this in green, right? A green highlighter. So if we look at, since 1980, if we look at this value, that's about half of this value, right? If we look at the divorce rate to the total population for the next year, that's about half of this number, right? And that's half of this and half of this, right? So you can notice that the divorce rate is about half of the marriage rate, right? Comparing those two. So that would support that idea. Another thing that would support this is looking at the divorces per marriages in that year. These are really close to 50%, right? So either the green or this pink color would support that idea, right? So there's two answers. Then 4 says, does the conclusion that roughly half of all marriages end in divorce logically follow these rates? So here we would say no, right? That conclusion doesn't really make sense, because in order for it to make sense, we need to track that, right? Because it doesn't really make sense that newlyweds would get divorced within a year, right? That doesn't seem practical, right? So we could say no. Most marriages last longer than 1 year, right? So it doesn't make sense to compare those. We would need to track marriages over time. Right? So we would need to track marriages over time to get a sense of how many end in divorce, right? To get a sense for how many end in divorce. Right? So this is something certainly that someone could collect data on, especially someone in the government, right? Because we could track marriages and divorces through Social Security number, right? Because those are used when you get married and also when you get divorced, right? And that's also identifying the individual person. So it could be done. So it's just important to note that our data doesn't necessarily logically follow that half of all marriages end in divorce, right? So you got to be careful with that, right? Because I could see some newspaper getting a hold of that type of data and coming to that conclusion, right? So it's important to be critical thinkers, have high quantitative reasoning skills to make sense of that and be like, no, that doesn't make sense, right? Or maybe you're the one writing the news article, so you need to be able to know that that I can't say that, or I can't draw that conclusion. So now number 5 says, consider the following XY scatter plot. In what year does the linear trend radically change, right? So if you look at this for a moment, where it starts to radically change is here, 1980, right? And then you also notice that it starts to go down from this, right? So what I would say is in 1980, there is a huge jump up in the divorce rate, and then it begins to decline, right? So we could use that to describe that, right? How that linear trend is radically changing. And then number 6 says, what could explain the divorce rate to start to fall after 1980? Right? So one thing is that we could simply just have fewer divorces. Right? So maybe after 1980, people are just choosing not to get divorces, right? So you want to note, though, that there could actually be more divorces if the marriage rate of the population were increasing, right? So even if the divorce rate were falling. So in fact, marriage rates were also falling. Living together and having babies out of wedlock became more socially acceptable during this time period. So perhaps these couples most likely to divorce just never bothered to marry in the first place, right? Leaving the pool of people that did marry to consist of people more likely to not divorce, right? So essentially what we're trying to say is, after 1980, maybe there was a social construct allowing people to not marry, right? So to have babies out of wedlock, right? Babies out of wedlock and not marry, right? So maybe individuals more likely to divorce simply chose not to get married, which means they can't get divorced. So maybe we had a better pool of people that were more willing to stay together getting married, right? That's what I was trying to explain there. So number 7 So it says, if you knew the number of new marriages has been declining since 1980, as more and more young couples chose to cohabitate, does that change your answer to number 6? So in a divorce rate, right, we would compare divorces to marriages, right? So marriages are on the denominator, divorces are in the numerator, right? So if we have fewer marriages here, then the rate should go up, right? But that's if this is being fixed. If this number isn't fixed, then my rate could still go down, right? So just because my number of marriages goes down, maybe the number of divorces also goes down, which could result in a lower divorce rate, right? So as we were saying. So no, it doesn't necessarily change my answer. So no doesn't change, right? We would need to look at the we would need to see what's going on with divorces, right? Because that rate could still be going down, right? So now number 8 says interpret the slope of the line as a rate, right? So the slope of the line was 0.1714, right? So interpreting that, we could say, oops, I'll have to type it off here to the side, right? So let me type off to the side and I'll make the font large. So you could say that the divorce rate per 1,000 marriages total in the population is increasing by 0.1714 divorces per year, right? So I modeled my sentence off very similar to the model that I told you to in interpreting the slope. So that's in the linear modeling guide and also in the textbook. Notice though in there I believe it says is changing by, and I said increasing by instead. That's perfectly fine, right? And I say increasing because it's a positive slope, right? So it is increasing that line. So you can do that or not, right? You could say is changing by instead of increasing by. And then lastly, number 9 asks us to find the equation of a line going through these points using X's years since 1980, and then use my line to predict the divorce rate per 1,000 marriages total in the year 2020. All right. So remember y equals mx plus b, right? My slope intercept. So what we need to find is I need to know slope, right? I need to know the y-intercept, right? That's to have an equation of a line. But if you notice, this point is in the form 0b, right? Whenever x is 0, the y-coordinate is my y-intercept, my b value. So I already know that b equals 22.7. So I don't need to calculate him, right? He's already given to me. But I do need to find slope, right? So slope is change in y over change in x, right? So we would have 18.3 minus 22.7 divided by 24 minus 0, right? So I'll grab my calculator up here. So 18.3 minus 22.7 gives me negative 4.4 in the numerator and 24 in the denominator. So if I divide this by 24, I get roughly negative 0.183, right? So that's m. So my equation is going to be y equals negative 0.183x plus 22.7. right? So I want to estimate for the year 2020, right? So in 2020, my x variable would be 2020 minus, fix that. So 2020 minus, so x is years since 1980, so minus 1980 gives me x equals 40. So if I plug 40 into here, I can find y, right? So we would take negative 0.183 times 40 plus, or I can do plus minus, or no, plus 22.7, right? Following my equation. Plus 22.7. Hit enter, we get 15.38. 15.38. So, in other words, we could interpret this as a sentence, right? So I make the font larger. So I can say the divorce rate in 2020, whoops. Divorce rate in 2020 is predicted to be 15.38 divorces per 1,000 marriages in the total population. Right? And how we're getting that y variable, right, is that is what the y variable is in the scatter plot, right? So it tells me, if we read this, it tells me what the y variable is, right? All right, so that's all there is for this worksheet. Make sure you let me know if you have questions. Thanks.